we can actually sense the signal in terms of the voltage or maybe current. So this way physical events or the characteristics are being looking like. So sensor is primarily a hardware device. So it is actually a hardware electronic device, and it can take the input from the environment and gives to the system by converting it into some of the electrical energy. So this way actually sensors are being working. And what is the actuator then? So actuator is nothing but actually it is a device. It can convert the electrical signal to the physical events. Like it is just the opposite of the sensor. But sensor can sense the other physical events from the environment, like an electrical signal, and the actuator can convert the electrical signal to the physical events. Okay, so like maybe for example, you can say that is the motors and heaters that are actually some of the commonly used actuators. Because using that kind of the actuators, we can actually convert our electrical energy to some of the speed, that is the velocity, or maybe in the terms of the heating. So these are the kind of the sensor and actuator. So like here we can see that is the some of the examples are being included here, like like a mercury in glass thermometer. So it can be used as a sensor. So it can convert the temperature into displacement of a column of the mercury, because if the mercury values are being rising or down, we can sense the temperature there. So this can be one kind of the sensor will be there, and maybe a microphone. So a microphone can convert the sound energy from the environment to some of the electrical signal. So this kind of the examples can be included as the sensors and actuators. Now, what is sensing basically? So, sensing is nothing but actually it is an electrical or mechanical or the chemical device. Actually, and that kind of the device can map the environmental attribute to a quantitative measurement. So here, each sensor, whenever we are actually working about a sensor, so each sensor is primarily based on the transduction principle, that is the conversion principle. So transduction principle means that is the conversion of the energy from the one form to the other form. Maybe from sound to energy, maybe from the heat to energy, maybe or maybe the vice versa. So this way actually we can convert these signals to some one form to the other form. Now, these are actually some of the sensing parts that is being familiar with our daily life. So we can see that is in our human body, there are the nose, ear, your hand, your fingers, your tongue. All these things actually can be working as a kind of sensor. So we can see that is our eyes can be detects the light, so it can be used as a sensor. Our ears can detect a sound, so it can be used as a sensor. Our mouth or our tongue can detect the certain chemicals, so it can be work as a sensor, because in our tongue there are some of the taste buds are there, and using that taste buds we can actually taste some of the foods, so it can be also act as a sensor. And maybe our plum that can be act as a sensor, like it can detect the pressure or temperature. So some of the basic requirements of the transducer. So whenever actually we are looking for the transducer, because sensor and actuator is a kind of the transducer. So what are the basic requirements we have to always find out there? So we have to first find out the rigidness. So rigidness means that is the how rough it is there, because sensor can be used in the any kind of the electrical devices, and that electrical devices can be used for the several actually practical applications. So the rigidness is the very important, so that it can match its characteristics to all throughout the different kind of the surfaces, or maybe throughout the different kind of the environments. Close करते हैं. Then also the another point is there, that is called the linearity. So linearity is an important factor, because whenever we are actually asking for the voltage versus current characteristics, or maybe some other characteristics, the linear nature, that is with the increasing of the voltage or with the increasing of the temperature, your voltage value can be constantly increasing. So that kind of the linearity is a very important perspective for requirement of a transducer. and there should not be no hysteresis. So hysteresis is the one kind of the losses is there. So we can assume that hysteresis is primarily the maximum difference in the sensor output at a pressure when that pressure is first approached with the pressure increasing and then approached with the pressure decreasing during a full span pressure cycle. So there should be a losses will be there, so that losses should be minimized. That is all the hysteresis losses. Then the repeatability also are very important because the nature of that sensor on the actuator uh, can be repeated in in your throughout the detection or throughout the module. You should have a very high output signal quality. The output signal quality should be very high, and it can be reliable and it can be stable, and that should have a good dynamic response. That is, depending on our user environment, the response can be changing, so it can be a dynamic response should be there. And another one is that the last point is that the no deformation or removal of the input signal. Like if my input signal can be changing or my input signal can be removed, so that there should not be any deviation or any kind of the other kind of the deformation should be there. So this requirements you should have to always keep in mind before designing of a transducer or sensor. Now, these are actually some of the physical principles that is based on that we are actually building or the manufacturing of the sensors. So, sensor can sense the electrical current, sensor can sense the sound and the wave and the other electromagnetic field signals. So, we have to follow some of the very famous law to manufacture the sensor qualities. So first of all, we can see there is the Ampere's law. So we all know there is the Ampere's law is there. So the Ampere's law is primarily stating that a current carrying conductor in a magnetic field experience a force. So this is actually getting us the Ampere's law, and from here and by using this principle, we can actually sense the current. We can sense the current in the case of the sensors. Then the um, QD law. That is actually so this is actually the transition temperature at which the ferromagnetic materials exhibit the paramagnetic behavior. So whenever some of the magnetic field we need to realize or we need to sense, at that time this QD law is a very famous law. In the Faraday's law of induction, it is also causing about the change of the magnetic field by generating the opposing voltage of the current. So this is the Faraday's law is there, and using that we are basically build the transformer, and using that principle we can also build the sensors. Then the photoconductive effect. So this photoconductive means when the light is striking to some certain semiconductor materials, the resistance of the material decreases. So and then only the current can be conducted. So this is actually the photoconductive effect. So using this photoconductive laws, we can also use this property as a sensor. Next one, now need for sensor. So what is the need for sensor? So we all know that is the sensor is the very important part of our daily life for the today's electronics application. So sensors are mainly, first of all, sensors are mainly omnipresent. So omnipresent means that is it can be used for a particular use. Suppose that if we are using the temperature sensor, so that temperature sensor will be used only to detect the temperature. Okay. If we are if we're having the sound sensor, so it will only actually detect the sounds from the outside environment. So these are the sensors used. So sensor will be always used for the omnipresent. Now, how they are being embedded in our bodies. So this is the application. So they can be embedded in our bodies, in the automobiles industries, in the airplanes, in the cellular telephones, in radios, in chemical plants, industrial plants, and other countless applications. We can use the sensor. Even we can see that is that today in today's life, everywhere we are using the sensor and actuator, because without the sensor and actuator, basically our life has um, actually our life has is coming to a limit mainly. So how do you choose the sensor? So whenever you have a sensor type or sensor characteristic, so you have to first think, or we have to first think that how we can choose a sensor actually. So it can be chosen by using the different factors. So one of the very eminent factor is that the environmental factors. So in the environmental factors, we should have to know about the temperature range. So what should be the temperature range will be there, and depending on that, what kind of the temperature we have to sensor we have to use, the humidity effect in the air, the corrosion, the size, the overrange protection, the susceptibility to EM interference, because in our environment the electromagnetic waves are there. So we have to always think about the EM interferences, the resistance, that is the current called the rigidness, your power consumption, and your self-test capability. So these are actually some of the environmental factors that we have to look after for choosing a sensor. Then some of the economic factors like my cost has to be minimized, my availability should be uh, introduced there, and the lifetime, that is the how much time it can be acted. So all these factors will be there for the economic factors, and different sensor characteristics, like depending on the sensor sensitivity, its range of application, like for what temperature it can be acted, or maybe for what amount of the currents, or actually what is the range of the current will be there for the sensor characteristics. It's of the stability, it's the repeatability, its linearity, its error, its response time, and its frequency response. So all these things are being dependent on the sensor characteristics. So detectable phenomena. So these are some of the phenomena that where actually we should have to measure which kind of the quantity. So mainly we can see that is if we are using the sensor in a kind of the acoustic, so we have to actually quantify the sensor in the terms of the wave. So in the wave, that is the amplitude, phase, the polarization, the spectrum, and wave velocity. So these factors will be quantified that thing. The biological and chemical cases, we have to see for the fluid concentrations like gas or liquid. In the uh, electrical case, we have to go, we have to see for the charge, voltage, current, electric field, your conductivity, your permittivity, and the many others countless things. And the magnetic, we have to see about the magnetic field, like what should be the amplitude, phase, the polarization, flux, the permeability. So all these factors will be quantified for the case of the magnetic sensing. And in the case of the optical, we have to see for the refractive index, the reflectability, and the absorption of the materials, and all other aspects we have to see there. In the case of the thermal stimulus, we have to see the temperature, the flux effect, uh, the specific heat and thermal conductivity nature. And in case of the mechanical, we have to see the position, the velocity, the force, the stress, and the torque, pressure. So all these detectable phenomena should be there. So this is actually the describing the sensor performances. So already actually we have briefed about it. So just to make it elaborate, we can see that how the range can be find out in the case of the sensor performance. So as I already detected that sensor performance is depends on the maximum and the minimum values that can be measured. So if I want to measure a sound, so for that sound signal, we should have a maximum value and the minimum value of that sound signal. That range should be defined there. If we have to go for the resolution or the discrimination, then we have to see that is the what should be the very smallest change in the measured value. That is, if suppose the environmental value has been changing, so what should be the minimum amount of the change is there? That is called the resolution or the discrimination. And the error also there. So there are mainly the two kinds of the errors we can detect: the random and the systematic errors, and we will be coming it actually later. So mainly these, depending on these two kind of the errors, we can see that what is the difference between our measured value and the actual value. So actually we have to see that is the what should be the value it can sense, and what is the actual value that present in the environment. So between these, we can measure a error there. and the accuracy, inaccuracy, and the uncertainty. So accuracy is a measure of the maximum expected error. So all these things are describing the sensor performance. So, and another one is the very important thing that is called the precision. So precision can be of the three types, like the low precision or the low accuracy, then the high precision, and maybe depending on the different accuracy, it can be measured. So we can see that is precision is actually a measure of the lack of random errors. That is the that is called the scatter. So actually, whenever we are measuring some values, we have to see that is what should be its actual range and what is its readings are there. So between this, we can actually go for the precision and the accuracy. So we can see here that is the first figure A is the low precision and the low accuracy. So we can see that is this is actually your actual value of the actual value is there, and these are actually the readings. So we can see that is the readings are not being matched with the actual value, and also whatever the readings we are getting at the different time or for maybe the different situations that are also being getting as a scattered value. So we can say that is in this case the precision is low and accuracy is also low. So this is what the low precision and low accuracy measure. If we are coming for the high precision and the low accuracy, we can see that is the all the measured values, that is whatever the readings are there, they are uh, they are nearly equal to each other. So they are actually concentrated at a certain range. So we can see that is this is called the high precision. But the actual reading and your measured readings are actually very much different. So it is called the low accuracy. So this kind of the measurement can be called as a high precision and low accuracy. And whenever we can see that is the all the measured readings and your actual values are being actually coincide in a nearly a certain a point, so that is called the high precision and high accuracy. So these are the three different kind of the measures we have to check for the sensors, that is how much precision and how much accuracy the your sensing device can be providing. Then another sensor performance is the linearity. So linearity is a very important factor because we all know that is whenever we are measuring something, our change of the voltage or current with respect to time should possess a linear value, so a straight line value. So that is called actually the linearity. So we can see here that in the case of the linearity, we should have that is the maximum deviation from a straight line response. So if we have a straight line there, so what should be the maximum deviation can be occurred? That is called the linearity. That is maximum difference can be occurred. That is called the linearity. So this linearity can be is being normally expressed as a percentage of the full scale value. Okay, so full scale value means that is the whenever actually we should have all the voltage parameters, current parameters, and maybe also some of the other physical parameters are already defined. So what should be the percentage of its actual value of the measured value? So that is called the linearity. So we have to check that is how much linear is this. That is the characteristics is how much linear. So we have to always check that thing. Next one is your sensitivity. So sensitivity is also a very important factor because it is actually a measure that change the produced at the output for a given change in the quantity being measured. So whatever the inputs is being given, based on the input, what is our output? So how this output can be produced and how this output can be changed with the change in the input condition. That is called the sensitivity of that sensor performance. So now the different kinds of the whenever we are talking about the different types of the sensors, so we can see that is mainly there are two different types, like the active and passive type of sensors are being present. So now these active and passive type of sensors are mainly differed as per their uh, physical behavior. So it means that suppose that if we are talking about the active type, so in the case of the active type, this kind of the sensors or devices can send the signal into the environment and then measure interaction of signal from the environment. So some of the example for this active sensor can be used as a radar or sonar. So we can see that is the radar can send some signal to the environment, and then from that waveform or from the electromagnetic behavior, it can detect it back. It can detect it back. So a radar and sonar is maybe one kind of the active sensor. It can send the signal and it can also detect the signal. So that is called the active type of the sensors. In the case of the passive type, what we can do, we can only sense from the environment. That is, whatever is being happening in the environment, we can just record it, or we can just sense the signal from the environment. But in this passive type of devices, it is very much hard to send the signal into the environment. So, like as an example, we can have it as a video camera. So, in the video camera, using the video camera, we can only actually record our environmental happenings or the environmental signals. So but it can't send any signal to the environment. So that's why this kind of the devices is known as the passive devices. And there are the different type of the classifications are there by the different medium used. So that kind of the classifications can be done maybe based on the electromagnetic radiation of various wavelengths. So there will be the electromagnetic radiation will be there, the vibrations in a medium, so how much vibrating the medium is there, the concentration of the chemicals in the environment, because we have to sense from the environment. So whatever the chemicals are being present in the environmental changes, that should be detectable and by your physical contact. Okay, so that is what how we can contact with some of the other environmental items, or maybe sensing systems, so that can be using the physical contact. So using these, we can have the different kind of the sensors we should have. Next, these are actually the some of the practical sensors that actually we are basically purchasing. So these are the very useful sensors that is being available in the market, and we are actually using this kind of the sensing activities or sensing devices for our basic requirements of our practical needs. So we can see that is the one is the touch sensor. So we will having the detailed description in our next slides. So the touch sensor is a very important kind, wherever we can actually sense the devices by touching, that is by the pressure, by using the pressuring that thing. Tilt sensor, that is whenever we are tilting that, whenever we are just making it siding, so how much it is being behaving by using some of the uh, material, we have been sensing this thing. The encoders, so encoder is a one kind of the coding system. I hope that all of you know about the encoders, that we can actually encode some bits from our real world application. The bend sensor, it can be bending like this. So and the light sensor, it can be used as a photovoltaic lights. The temperature sensor, it can actually measure the temperature using some of the thermocouple. And the potentiometers, it can detect the voltage and current. And laser range finders, because today also we are using the laser lights to detect some of the ranges. So laser range finders is there, and then the cameras. So these are actually all the very kind of the practical sensors that we are commonly using in our labs and in our research activities. So this is the very first kind of the sensor. This is called the touch sensor. So touch sensor is nothing but a switch. So we can actually see this circuit here. So we can see that is that in this case, whenever we are making a force to this switch, so this switch can be actually getting here, and so the circuit will be completed, and then the current will be flowing, and we are measuring the voltage over here. So this is called the touch sensor. So in the case of the touch sensor, a force is required or a touching is required, and using that force or using the touching phenomenon, we can actually complete the circuit, and we can measure the flow of the electrical current. This is the touch sensor requirement, and it can be looking like this in the practical example whenever we are using in a device. Then it is actually a tilt sensor. So we can see that in this tilt sensor we are using some of the mercury material. So whenever actually using that mercury material, it can actually following the gravity. So whenever we are just tilting the device, the mercury material can be shifted to that side, and using that shifting of the mercury material, it can detect the environmental gravity, and also it can sense. So this is called the tilt sensor. And tilt sensor can be used as another type of the switches. So we can see that is by using the tilting effect, we can use this kind of a sensor as a switch. And these are actually the uh, uh, practical scenario of the tilt sensors. Next one is your encoder. So that is called the encode. So how we can actually encode the things. So encode means that is we all know that is whenever we have a suppose the practical digital system like suppose 2. Now in this 2, whenever we are actually learning it as a 0010, it can be used as an encoder. So here actually the encoders, but in this case encoders are being measured the rotational motion. So whenever actually we are being moving something, actually we can see this kind of the devices. So whenever actually we are moving this device, so depending on the device movement, square waveform can be generated. And due to this due to this waveform generation, we can say that is it can be on off, it can be on off, like in a digital system, like in the 0101 0101 pattern. So how many rounds we can be rotated it can be detected on the on off scenario. So we can see, so whenever we are just completing the one round, maybe that time it is off, but after one round, whenever we are again rotate it, it can be getting on. After that, whenever we are again rotating it, it can be off. Whenever again we are rotating it, it can be on. So like this, it can be going for a different rounds, like 1, 2, 3, 4, like this. So so that it can be actually used to measure the rotation of a wheel. So how many times the wheel can be rotated, it can be measured, that wheel rotation. And in this case, actually very well-known example can be as a servo motors here. So in the case of the servo motors, actually it can be used in the conjunction with an electric motors to measure the motor's position, and in turn the control its position. So these are the encoder, the kind of the sensor. So next one is your actually bend sensor. So in the case of the bench sensor, mainly it is working in a principle of the resistivity. So whenever, so how we are changing the resistances of a material. So we can see this example over here. So whenever actually we are building some material, their resistance can be changing. So if the resistance can be changing, so using this formula, we can easily know that is my voltage value can be changing. So so that it can be sensed, because sensing can be done using the voltage measurement value, that is in a kind of the electrical signal value. So if the resistance can be changing, my voltages also can be changing. So we can assuming that the constant current, the measured voltage changes with the resistances. So it is called the bend sensor, and it is also very much useful to check the resistance of a material. So we can see that is the in which temperature what should be the resistance of a material, and then according to that we can check that how the bend sensor can be working out. Then next one is your light sensor. So light sensor, actually this is based on the principle of a photodiode. So we can see that is the light sensor is looking like this, and this is being widely available in the market, and we are using it in our lab, in our research purposes, in our industry, in our daily life, everywhere. So in this case also, it is being working on the phenomenon of the resistance. So in this case, mainly we are using some of the PN junction diode, because it is a photodiode, and we all know that is the diode can be made by a PN junction. So whenever the light falls on a PN junction, it can be used to generate electricity from the light energy. Okay. So because its resistance can be changed, and that's why some currents can be actually flowing. So it can be it can be generate some electricity from the light energy. That is, the current can be flowing, so electricity can be generated over here. So some of the small devices used as sensors are called the photodiodes. So photodiode is a one kind of the light sensor is there. It can be fast acting, but the voltage produced is not linearly related to the light intensity. But in this case, what is the problem is there that we can't actually produce the voltage in a linear nature with the light sensitivity. Next one is your temperature sensor. So it is actually working in the principle of the temperature. So how the temperature can be changing here. So we can see that is a temperature sensor is mainly a device. Actually, it is used to measure the amount of the heat energy, because temperature is a one kind of heat that can be present in the environment or with a maybe a surface. So to measure the amount of the heat energy that allows to detect a physical change in temperature from a particular source and convert the data for a device or user. It is known as a temperature sensor. That is, it can be actually coming from the temperature. So whenever some environmental change in the temperature can be happen, it can detect the temperature, and due to the detect of the temperature, actually the registered value of the materials can be changing, and that's why it can supply the data that is in the form of the voltage or current to the device. So this is a very well-known example that is called the resistive thermometers. So in this case of the resistive thermometers, we are basically use the platinum wire. So we can use the platinum resistance thermometers or PRT there. It may be linear, but it may have some of the port sensitivity. So different kind of the temperature sensors are being available there in the market. We can see that this is the one kind of the sheeted PRT is there, and this is a typical PRT. So through which actually we are sensing the temperature from the environment or maybe from a particular item or material. So temperature sensors are further can be divided into two types. One type is your thermocouple, and another type is your registered temperature detector. So firstly, we are being moving towards the thermocouple. So what is actually thermocouple? So we all know that is a thermocouple is a sensor, and it is can be used to measure the temperature. So whenever we are actually getting the thermocouple, so the basic policy of the thermocouple is that in the case of the thermocouple, it can consist of the two wire legs. So there are two wire legs are there, and that two wire legs are being made by the different metals. Now the wire legs are welded together at one end and creating a junction. So these wire legs will be welded and they are creating a junction, because thermocouple is based on the principle whenever two different material can be coming together and they are being welded, so that their change in temperature can be balanced out. So that is the principle of the thermocouple. So in this case also the same thing, like the wire legs are welded together at an end, and this can be creating a junction. Now the junction is where the temperature is measured, and when the junction experiences a change in temperature, then a voltage can be created, because there are two different metals are there. So maybe that two different metals has a two different uh, form of the resistivity. So whenever actually some temperature can be happened, their expansion growth can be different, and that's why we are uh, having a different voltage value, and that voltage value can be sensed by the sensor, by the temperature sensor. So we all know that is whenever we are actually using the thermocouple materials, for that case we are generally using the copper or the constantan type of the material, or maybe the iron constantan, or maybe the chromel aluminum. Hmm? So these are the different kinds of the thermocouple materials are being there. So using that thermocouple materials, we can see that is the using the thermocouple materials. If we can actually use the two type of wires, we can see in the figure here, like this is the wire type A and this is the wire type B, and these two wires are being actually welded in some point, And whenever we are actually giving the heat to the junction, there are the different expansion of this case, and depending on the different material behavior, your voltage value can be recorded, and it can be sense your temperature. Next one is your so in this case, as temperature goes up, the output voltage of the thermocouple can be rising. Next one, the concept is that the RTD. RTD means that is called the registered temperature detectors. So this you can see as your RTD device, and where actually we are putting a RTD bulb there. Now this RTD is being generally, this is actually a resistance of the device is directly proportional to the temperature. So whenever the temperature is increasing, the resistance can be continuously reducing or maybe decreasing depending on this uh, on the material behavior. So increase in a positive direction when the temperature rises, resistance going up. So it can be whenever the temperature can be rising, it can be going up there. And another one is your the thermistors. So in the case of the thermistor, it is actually a temperature sensitive resistor, and it can change its physical resistance with the change in the temperature. So these are actually the different kind of the temperature sensors that basically we are using. Then another one is your force sensor. So force sensor is being completely depending on your mechanical properties. So whenever we are depending on the mechanical properties, it is being coming in the form of a strain gauge. So whenever we are seeing that whenever we are using the strain gauge, so it can be stretching in the one direction, and that's why it increases the resistance of the device. So whenever we are stretching in one direction, the resistance of the device can be increasing, and while the stretching in the other direction has little effect. So this is called the strain gauge is there. So and on this phenomenon, basically your sensor can be working out. And in this case, it can be bonded to a surface to measure the strain. Strain means that is the how much we can make it flexible, or how much is its tensile strength is there. So that portion we have to see here, and it can be used within the load cell and the pressure sensor. So this is actually an example of the strain gauge, and there are actually two parts we can see. So depending on the strain or depending on the tensile strength of these two parts, we can actually measure the force sensor over here. Then the potentiometer sensor. So potentiometer, we all know that is whenever we have a knob, and if we are moving the knob in a some particular direction, your resistances can be increases or maybe other decreases. So depending on this phenomenon, that is how it can be rotated. That is depending on its position, its resistance can be changing in a potentiometer, because in the case of potentiometer, we should have the different resistance values at the different point. So whenever we are moving the knob, we should have the different values of the resistances there, and that's why it can actually sense the change of resistances in the form of a voltage value. That is called the potentiometer sensor. Next one is your sound sensor. So in the case of the sound sensor, it is a very well-known example of the microphones. So maybe using the microphone, there is a number of other forms can be available. So in the case of the microphones, we are generally using the different kinds of the microphones, like in the carbon or resistive type, the capacitive type, the piezoelectric type, and the moving coil microphones. So we can see that is the whenever the sound waves are being generated, your microphone can be detect the sound wave, and it can actually giving you the output voltage value. So this is actually your microphone output voltage, and in the form of the output voltage value, our sensor can detect the sound. So that is called the sound sensor. Next one is a gas sensor. So it is a very well-known sensor, and this kind of the gas sensor is primarily used um, for our aeroplane, or maybe for our other kind of the military applications. for some secret applications, we are actually using the kind of the gas sensors. So mainly, the gas sensors are defined as electronic devices that can detect and identify the different types of the gases. So it can actually detect the what are the different kind of the gases are being present in the air. So maybe it can detect also the different kind of the toxic gases or maybe the explosive gases in the air. So there are different kind of the gas sensors are being also available in the market. Like if we want to use the carbon dioxide based gas sensor, then then it can detect the CO2 or maybe the nitrogen dioxide or maybe the carbon monoxide. So what kind of the sensors are being there? We should have to detect detect that kind of the gas sensor. We have to use that kind of the gas sensor there, and this type of the gas sensors are being often part of a larger embedded system. So because we are actually using it for some of the defense purposes or military purposes, or in the case of the aeroplane. So that can be a very much large embedded kind of a system, and it can be used in a security kind of systems, the gas sensors. So it is a very important sensor application. Now, different kind of the gas sensors are being also available there in the market. So we can have first a metal oxide gas sensor. So metal oxide means that we can use the MOS, that is MOS, to sense and detect the various gases. Because we all know that is in the case of the MOS oxide, it is actually metal oxide semiconductor. So in this case, we are having the different kind of the doping concentration, and using that different kind of the doping concentration, we can sense the different kind of the presence of gases, and that kind of the gases can be used to sense the kind of the gas sensor. Another one is your optical gas sensor. So this optical gas sensor can be monitored by the optical absorption of a gas species at defined optical wavelengths. Because whenever we are moving to the optical field, it is very important to have that is how it can be acting there. Because in the case of the optical field, it is it is primarily based on the wavelength. So depending on the different wavelengths, the optical gas sensor can be working out. So in this case, the distribution of the optical absorption or the emission with wavelength provides an optical fingerprint for any gas species present. So whatever the gas species can be present, for that case, we can generate the different kind of the fingerprints there, and the magnitude is typically shows the concentration of that gas of the present gases. And we can see that is and we can also have that different kind of gas sensor that I already actually uh, conveyed. So if we are using the carbon dioxide based gas sensor, so it can measure the gases of the carbon dioxide level in an environment. So in our surrounding, so how much percentage of the carbon dioxide is being present there. So it can be measured in the range of the 0 to 5,000 ppm. So you can see that this is a carbon dioxide based gas sensor which is available in the market, and we can also monitor that how much infrared radiation is absorbed by the CO2 modules, that is the carbon dioxide module. And these kind of the sensors can be used as a aerospace, the indoor air quality monitoring at our home, in the case of the agricultural applications. So in all these cases, we can use the carbon monoxide based gas sensor, and it is very useful actually for our current purposes. So these are some of the basic pros and cons for the carbon dioxide based gas sensor. So in the pros, actually, we can see that the CO2 based, sorry, actually, this is the CONS. There's a typo mistake is there. So we can see that this is the different pros is there. Like in this case, it is very easy to operate in the absence of the oxygen because it can detect the carbon dioxide level in the air. So and another clause is there that the optical gas sensor is not affected by the electromagnetic interference because optical gas sensors is only used based on the wavelength. So there is no so there is nothing for the electromagnetic interference is there. and the optical gas sensors have very wide monitoring area because the wavelength of the optical gas sensors is very wide, and so that we can use it in a very wide monitoring area. But some of the also drawbacks or maybe cons are also there. So it is affected due to the ambient light of the interference, because if the low light is there, so it can be affected. Uh, it's the stability is very poor, and it has a very greater environmental impact. So if something change is happening in the environment, so maybe it can be changed. Uh, that is, its sensitivity can be changed, and it cannot be used in places where the accurate measurement is required. So these are some of the cons are there, uh, but still it is a very important factor. Another one is your also very much important sensor is it is called the humidity sensor. So this humidity sensor can sense, measure, and reports the the moisture quality and the air temperature. So how much moisture is being present, how much percentage of the moisture is present in the air, it can be detected by the humidity sensor. So it is actually referring as a ratio of the moisture in the air to the highest amount of moisture at a particular air temperature. So it's called the relative humidity. Actually, it can measure the relative humidity because we have a actually as per our environmental department, there should be a particular value of the humidity can be present there. So now referring to that humidity, how much percentage of the humidity is being present at present in the air, that can be measured. So that is called the relative humidity. And it can measure the relative humidity part. So we can see that is this is actually uh, a humidity sensor type. It is being available also in the market, and we can also using some breadboard, we can also detect the temperature and the humidity like this. Okay, and using some connection and using some LED display, we can actually measure the humidity type of the like this. And actually our students are mainly doing this kind of the experiments, and they are measuring the the uh, the air moisture, the soil moisture, and the other maybe the fridge temperature, the microwave oven temperature. So all these kind of the moisture and temperatures, they can be detected. Next, now these are actually the different types of the humidity sensors are there. So so mainly the capacitive type is there. So mainly it measures the relative humidity by placing a strip of metal oxide between the electrodes. Because in the capacitive nature, mainly we are placing the two metals, and in between there is a insulator is there. So in this case also we are doing the same thing, that we are placing the metal oxide between the two thin strip, and it can be act as a capacitive humidity sensor. Another one is the resistive type. So in the case of the resistive type, actually we are using the electrical impedance of the atoms. So whatever the atoms are being moving in our environment, so what should be its electrical impedance? So that can be uh, presented as a resistive type of the humidity sensor. The thermal humidity sensor, so we can have the two thermal sensors are being there, so that can conduct the electricity based upon the humidity of the surrounding air. So basically it can be treated as a heat. So here actually one sensor is encased in dry nitrogen, while the other measures in the ambient air, and the difference between two measures the humidity. So in this case actually, here we are having the two kind of the thermal sensors we are generally using, and that two thermal sensors are primarily worked based on the humidity of the surrounding air. So out of these two thermal sensors, one is being encased for the dry nitrogen, and other one is for the ambient air. Now, whatever the measure between these two, the difference is that to measure the humidity is there. So these are the different pros and cons of this humidity temperature. So we can see that is the pros, that is the advantages are there, like the capacitive humidity detector hydrogen can provides the linear voltage output. It can provides the linear voltage output, and the sensor has a very low cost and a very small size. So it can be fitted in the different kind of the devices and circuits, and different cons can be there, like in the capacitive type, the distance from the sensor and the signaling circuit is very limited, because in the case of capacitance, um, through this, so that we can measure the distances, and the resistive type sensors are sensitive to chemical vapors and other contaminants. So these are some of the different drawbacks are there. Next type is the motion sensor. So by the same way, in the case of the motion sensor, actually it can detect and measure the movement of the some movement of something, like movement of the some of the factors, or maybe some of the species in the present in the environment. So this kind of the sensor is being primarily so active. So there are two kinds of the motion sensor are there. So mainly first type is the active motion sensor. So in the active sensor, we have already seen that is using the active sensor, what we can do, we can send a signal to the environment, and we can receive a signal to the signal from the environment. So it is also the same thing, like this type of sensor can detect the motion by measuring the changes in the amount of sound or radiation reflecting back into the receiver. So how it can be sending the signal, and how you are actually receiving the signal from the environment. And active motion signal can transmit the radio frequency towards the person or object, and analyze the receipt frequency to determine the motion. So this way actually it is being acting, and this is the one kind of the active motion sensor that is being available in the market. And next one is the passive motion sensor. So in the case of the passive motion sensor, it can't it can't transmit a signal. It can only take the reflection back from the environment. So in this case, in the case of the passive motion sensor, we are generally using in a home security system. In the form of the passive infrared sensor. It is called the PIR sensor. So in this kind of the sensor, how it is been detecting, like when maybe a human or maybe anybody comes to the nearby, it can sense the thermal energy, like the temperature of that component, or maybe of the human body, and then compare it to the normal room temperature, like the normal condition, and then it can sense. So it is acting as a motion sensor. And there are some pros and cons are there for the motion sensor. So it can help to conserve the power, and decrease the electricity cost, because it is been working as in a type of the infrared type. And it detects motion in light and dark condition reliability in indoors, and it helps in improving the security by detecting the suspicious movements. So so these are some of the pros is there, but some of the drawbacks are also there, like the radio frequency at high power is harmful for the humans, because it can working in the infrared. So it may be um, drawback for the humans. And the passive motion sensor do not operate above the temperature of the 35 degrees Celsius, because it can only sense that thermal energy from the environment. So there is a limitation of the temperature is there. And the passive type is also insensitive to very slow motion of the object. So these are some of the drawbacks are there, and some of the pros are there. So we can see that is everywhere we can have some of the drawbacks, some of the advantages are there. So these are some of the practical applications of the motion sensor. We can see that in the case of the home automation, we can use the motion sensor. So, so maybe it can detect the up to 5 meters, or maybe as a 16 feet away, and it can be triggering a bulb, or maybe a scene within a half of second. We can actually measure the motion sensor in the ticket gate, like in our metro station, or maybe in our cinema hall, in our airport. We can actually use this kind of the gates are there, and there also we can use this kind of the motion sensor. And and some of the maybe antisocial behavior in the bank, or maybe somewhere else, we can also use this kind of the motion sensors. And now, these are some of the problem in the sensor placement, that we have to first see that how we are actually, where do we put the sensor system there, and how it is being used as a on or off board. So if it is used as a one board, matlab, if we are using it in a on a breadboard or on a PCB board, so how it can be using it there, how the arrangement can be there so that there should be minimum hysteresis losses there, and the optical arrangement should be there like that it can be mathematically rigorous and we can actually detect these things. So now these are actually the all the available sensors are being there in the market. So now actually I will be put some light on the nano sensor, and this is my last actually the last topic is there. So basically in the case of the nano sensor, some of the kind of nano sensor is being already available in the market, but we are still uh, perform our research in the case of nanosensors. And if you can go to the IIC Bangalore INUC facility lab, we can see that there is a huge research is being going on based on the nanosensors, because the application of the nanomaterials can be very much useful for our environment. We are using generally the organic materials there, so that may be the very much advantageous for us. They can be recyclable, they are not being harmful to our society, and also they are not being and also they are non-toxic. So we can also use the nano kind of the sensors for, as a biomedicine also. So this is a very important direction for the future research. So in the case of the nanosensors, mainly we can see that is that a nanosensor is a sensor that created on the atomic scale that obtains the information about the nanoparticles and translates it to a scale we can easily analyze. So here actually as a sensing material, we are mainly using the nanoparticles. It means that the nanomaterial, and using that nanomaterials, it can actually receive the information from the environment as a nanoparticle, and it can also be translated back into the nanoscale devices or nanoscale property. The main advantage is that the size is being very small, the weight can be very low, and also it has a very much modest power requirements, like the power requirement is also very less. It has a data storage system, and we can use it for the biological, chemical, and the physical sensory points, and it can use to convey the information about the nanoparticles to the macroscopic world. So this way the nanotechnology or the nanomaterials can be dependent on. Now this is the kind of the nanosensors. So first of all, uh, in the case of the nanosensor, mainly we are using the various kind of the one-dimensional nanomaterials, such as the nanowires or the nanotubes. Like some of us are being also working in the different kind of the nanowires or nanotubes, like the silicon nanowires or maybe the carbon nanotubes or maybe the graphene nanoribbon. So all these kind of the different nanomaterials can be used as a nanosensors. So it can be very much easy as compared to the bulk or the thin film planar devices. So some of the nanosensors can be used for the defense applications that can be included for the detection of the explosive or the toxic gases, because it can be very lightweight, it can be non-toxic, so we can actually use it for defense purposes and some security purposes. And the nanosensors also possesses some of the great potential for the diagnostic medicine and enabling the early identification of disease without reliance of the observable symptoms. So basically, this property is being primarily working based on the non-toxic nature of the nanomaterials. So we can easily consume to our human body, and it can actually helpful to us to detect the any kind of the diseases. So we can see here that this is actually a graphene sheet is there, and this graphene sheet can be used here as a sensor position. And this is also a nanobacterial sensor where actually we can use as a bacteria. Um, Even currently also we are being working in the nano filters. So there also we can use this kind of the nano sensors to filtering out the the particle uh, present in the environment, like 2.5 micrometer or maybe lesser. Then the flexible sensors. So these nanomaterials, actually the main advantage of the nanomaterials are that it is very flexible. So it can be also used as a flexible sensor. Right? Suppose that if you can use the OLED, like that, the organic LED devices, or maybe the OTFT, like the organic thin film transistors, they are being very flexible in nature, and due to their actually deflection or the bending curvature, it can be useful as a flexible sensor. So this kind of flexible sensor is going primarily depends on the variation of the resistive components, because whenever we are bending some material, so their resistivity can be actually increasing or decreasing, and depending on that, we can mount it on a surface. And the amount of the resistance here, the deflection, can be measured on the basis of the bending of the flexible sensors. So these are some of the applications of the flexible nanosensors. So we can actually use it in the different areas, like for the environmental monitoring, the security systems, the robotics, the body health monitoring system, your the watches, the smart cell phones. Because Samsung has already produced the flexible cell phones, so we can use as a cell phones, and then the flexible displays, and mm, and the computer interfacing, and the flexible panels, the the electronic screen, the wearable sensors. So in all these cases, we can applicable. It can be applicable the flexible nanosensors, and it is a very great area of the research for the future. So this is can be the biosensor. So the biosensors can be used like a cell-like structure. So this is actually the one kind of the, you can say, there is the analytical device that can be incorporated a biological active element with an appropriate physical transducers to generate a measurable signal proportional to the conception of the chemical species in the any type of the sample. So mainly we have to use this kind of the nanomaterials to maybe as a compatible device to our chemical properties of our medicine, or maybe to our the medical instruments. So these are the some of the cases we are using this. These are the samples, like the different samples we can be present here, and it can be used as a transducers and the electronic systems. It can be detected as a biosensors. So we can see in the more elaborative part that how the nanobiosensors can be actually working, that the nanowires can be used here as a biosensor. So it can be used for the different treatments, that is called a serum, toxin, antitoxin, vaccine, virus, blood component, and the allergenic product, and the analogous product, and the derivatives applicable to the prevention, treatment, and cure of the injuries and diseases of the man. So it can be used for the different detection of these cases, and this is also a very great area of the research for the medical biotechnology. There actually we can use this kind of the nanobiosensors there, and this kind of the nanobiosensors are also used to detect the asthma attacks up to the 3 weeks in advance. So mainly currently uh, the biochemical lab of the IIC Bangalore is currently working on the nanobiosensors to detect the asthma attacks. So how it can be detect the asthma attacks, or maybe the other kind of the blood clotting related attacks in advance. So that is being working. And this is actually the structure, some like of the structure of the nanobiosensors. So here we can see that these are actually all the scale in the nanomaterial scale, and these are actually working as a like this. That is, these are the very teeny particles are there, and using these teeny particles mainly we are detecting our body symptoms in advance. And in the military and the national security systems, so it is a very lightweight material, and it can be a very portable kind of the chemical detection. So it can combine the nanomaterials for the different kind of the sample collections. So in this case we can use this as a chemical lab on chip detector. So chemical lab on chip means that whenever uh, we are assembling the different kind of the components on a chip, like the on-chip material that is called the chemical lab on chip, and this way actually we can develop some kind of the VLSI chip or the nano chip in the future, and and it can be very much useful for that. So this is the end of my slide. So in the summary, I must mention that in this talk I have covered the different wide range of the sensors, and we have seen that is the some sensors can produce an output voltage related to the measured quantity, and therefore it can supply the power, and other devices can simply change their physical properties, and some sensors produce an output that is linearly related to the quantity being measured, and others may do not, because there are some pros and cons for the every sensors. So that already we have demonstrated here. So so these things can be there, and the interfacing can be maybe required to produce the signals in the current form, because whenever we are using the transducer, it can actually convert one particular energy to some other energy, like maybe some sound energy to the electrical energy, or maybe the thermal energy to the electrical energy. So that conversion of the signal should be in the correct form. And also there must be several challenges is there that already we have discussed there. So another one is that the reducing the cost of the materials and devices. So whenever we are designing some of the electronic devices or electronic applications, our main motive is that how we can reduce the cost of the material and the devices, so that it can improve the reliability of the material and the packaging of the devices into the very useful products, because the packaging is a very important part whenever we are actually fabricating an IC. So we have to must know about the packaging type, and the mass production. It means that is called the batch fabrication. Whenever we are producing the ICs, that time we should have to know that is how we can produce the similar kind of the thousand of the ICs at the same time with a minimum effort. That is called the batch fabrication, and the different methods are typically being incompatible with those used in the making electronics. So and finally also we have focused some light on the nano wire based sensors. So it is a very open area for the future, and people are very interested to work in this nano wire based biosensor, in the nano wire based security sensor, and the various other applications also there. So thank you for all of you for your patience. If you have any questions, please.
Thank you, Dr. Manoj, for giving such a wonderful talk in this online FTP session here to the participants. So, as one of the responses already speaking, and that all the questions have been answered through your presentation. Okay. So, if you have any questions or if any doubt here, so you can ask to the chat to the Manoj sir here. However, I think I can see one question have been asked to sir here by one of the participants from Ravikant Soni.
Yeah.
So his question is: rapid test currently performed all over the India for corona can be example of these biosensors.
Yeah. So so this is actually a very good question. Yeah, we can also use the rapid test kit as a nano biosensor, obviously. But whenever we are coming to the nanomaterial, there are some of the fabrication challenges is there, and that fabrication related challenges we have to first actually accommodate to our study, and after that maybe we can go for the production of a in a commercial basis or in an industrial basis. So maybe at present, the different research universities or research industries, they are actually working to relate on this fabrication related tasks, because in the case of the nanomaterials, first of all, we should have to know the compatibility with the current technology. Currently, we are using the silicon technology, so our nanomaterials should be compatible with the silicon technology. Then only we can use it for our industrial production. So yes, obviously we can use it for the rapid test, but till now, um, actually, we have to first relate the challenges on the fabrications, and maybe after that we can use it. Uh, yeah,
So
thank
any
you.
other question from your side?
Okay.
Okay. So with this, I assume here there's no further questions to the Dr. Manoj. Yes, any question, please?
Uh, this is Rajeshwar from Chandrapur, sir.
Yeah.
Actually,
Okay.
nanobots. We know that coronavirus is actually infecting the, or you can say it is choking actually the respiratory system,
Yeah.
isn't it?
Yeah.
Uh, Using nanobots, can we make any kind of thing that will unchoke the things, or directly we can directly attack the choking material of your lungs or something like that using those nanobots which will directly attack those choking material. Can't
Yeah.
we produce such kind of nanobots, sir?
Yeah. Uh, so thank you for your question, Rajeshwar. So actually, I must mention here that currently that what is the industrial progress what the people is working, that they can detect, actually they can detect earlier that if there is any infection or maybe there is any chance of the infection is there. So suppose that in the current scenario of the coronavirus, basically whenever a person is being affected by the coronavirus, that time uh, there should be a stages there. Like suppose that before 3 days, our uh,
Hmm.
our body is actually getting the antibody production. So using that nanobio sensor, we can obviously detect that thing. That if our system is being getting to use as a nanobio, yeah, to make it for a um, antibody generation or not against the coronavirus. So that maybe we can detect it.
Yes, sir. And after detection, we can't make such kind of nanobots which will clear those choking means,
Yeah,
by
actually,
doing some kind of
yeah.
uh, any sort of we can say laser treatment doing on that particular thing. Such kind
Actually,
of
sir, yeah,
right?
actually, sir, this is
Not
still,
exactly laser.
yeah, yeah. Actually, sir, this is still in the research phase. So maybe in future it can be happened, but actually still now
This
there is no evidence there, sir.
actually, sir, these nanobotics, whatever we are just using them as a detection material, right?
Yeah,
Till now, okay, we
still,
can
yeah, till
make
now
it.
it can be detected. Actually, it can detect
It is
diseases.
detection of any kind of disease.
Yeah, it can detect any kind of the diseases in advance,
Right
maybe.
now, yeah, right now we are facing in last 10 years we have seen a lot of viruses
Yes,
like then corona. Maybe in future we can get
correct.
COVID-19 instead of 19 version 1, 2, 3, 4, whatever it may be.
Yes,
So
yes.
instead of just detecting, can't we produce nanobots which will kill these kind of viruses?
Yeah,
Uh,
actually, sir, the thing is that it can detect in advance. So suppose it is also being advantageous. Maybe using that nanobio sensor, if we can detect the disease earlier, so that we can make the prevention there.
yes,
So that can be also being very much effective for our future. So actually, people have already detected the asthma attack in advance. Actually, that I already told you. So and actually, people are also trying to make them in the production stage.
mm,
Even some of the surgical uh, operations also we can do inside our body using this kind of the nanobots or the nanoparticles. So in that case, it can be affected. But after having this virus for the prevention case, it is still in the under
yeah,
research. Under research. So maybe one day we can come up with this solution, sir.
yes. Means nanobots in future we can research on that as a
Yeah.
fighting tool for human body,
Yes, sir.
isn't
Yes.
it? Thank you so much.
Thank you so much, sir.
So any other query from any other participant? Okay. No. So with this, I assume here there's no further questions to the Dr. Manoj here. So from the organizing team, now we would like to represent memento here as a token of love from Triple IT Nayarapur to the sirs here.
So thanks to all of you, and I would like to also thanking to the coordinator, Dr. Sri Vishal Tripathi, our institute, our AICT director for conducting a nice event. Yeah.
So with this, okay. Thank you, sir,
Thank you so much.
for being present.
Thanks to all the participants.
So in case of this virtual mode of communication here, we need to bear with some new methodology here to further move on. So with this, I announced here this end of the first technical session here, and after a 5 minutes break here, we will meet again. So it is 12:07, so 12:12 here, we will meet again for the second session. Thank you very much.
Thank you, sir. Thank you.
Okay, thank you so much. May